Hi guys, Miss Brummel here. Okay, so in this video, I'm gonna go through our notes for 1.6. Sorry, let me zoom out just a hair more. Okay, and I'm actually gonna go a little bit backwards. So we're gonna start with something that you guys should already be familiar with, and that's the Pythagorean theorem. And so just a reminder, here's our generic formula, a squared plus b squared equals c squared. So please write that down in this box, and then I'm going to go to the Pythagorean theorem examples. And I'm going to start down here with the two triangles. So the Pythagorean theorem only works for right triangles. So you'll notice in both of these examples, that's exactly what we have. And I'm going to start with this bottom one. So it says find the length of the hypotenuse. So remember, the hypotenuse is our longest side. In our equation, that's C. So the other two sides are called the legs. That's A and B. And it doesn't matter. I could switch these. 8 could be B and 15 could be A. That part does not matter. The most important thing is that C has to be the hypotenuse. So we're going to set up the Pythagorean theorem that 8 squared plus 15 squared, those are my A and B, has to equal C squared. Okay, so now I'm going to go ahead and follow order of operations. I'm going to do the exponents before I add. 8 squared is 64. 15 squared is 225. Add those together, we get what? 289 equals C squared. Okay, and so I'm trying to find C, not C squared. So the last step is to undo a squaring, as we're going to square root both sides. And then this is where I can use my calculator to check, is it a perfect square? And if it is, then that's my answer. And this one is. Square root of 289 is a perfect square, it's 17. If I got a decimal here, then I would want to use my simplify radical skills and write it in exact simplified form. So here we just got 17 is equal to C, and I'm going to add on my unit of inches since that's what the other measurements are in. So 17 inches is the length of this hypotenuse. Okay, the other example here is asking me to find the value of B. So I still want to set up the Pythagorean theorem the same way, a squared plus b squared equals c squared, and I need to identify C. So 12 is the longest side. It will also always be across from the right angle. So this is C. B, I don't know. And then the other leg is going to be A. So I'm still going to set up a squared plus b squared equals c squared. So 9 squared is a squared. B, I don't know, so I'm just going to write it as b squared. And then C is 12. So it's still set up a squared plus b squared equals c squared, and we've substituted in the correct spot. 9 squared is 81. 12 squared is 144. So we're trying to solve for b. So I'm going to get rid of this 81 and subtract it to the other side. So we got 144 minus 81 leaves us with 63. So b squared equals 63. Same thing, I'm going to square root. Now I know that 63 is not a perfect square. You can check that on your calculator as well. So if I tried to do square root of 63, I get this irrational number. So anytime you guys see that, we're not going to round, we're not going to use this answer, we are going to do the simplified radical. So I'm going to do, again, I like the prime factorization method the best, so I'm going to break down 63 into things I know multiply to be 63. So I know 9 and 7 multiply to be 63. 7's prime. 9, I can go further, 3 and 3. So 3 times 7 is 63. We have a pair of 3's. So square root of 3 squared is 3. And then 7 would stay underneath. So b is equal to 3 root 7. Okay? We can also use the Pythagorean theorem on a coordinate grid. So A is at the point 1, 1. We'll call that A. And B is at 4, 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so they want me to find the length or the distance from A to B. Now, I can just draw in a right triangle here. I know it's a right triangle because I just drew a horizontal and vertical line, which are always going to form a 90-degree angle there. And then I can just count the spaces. So this leg has a length of 3. This length, 1, 2, 3, 4, has a length of 4. And then the length from A to B, that's the hypotenuse. That's C. So then I can set up 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. So 25 equals C squared. This one's a nice perfect square. When I take square root of 25, I just get 5. So the distance from A to B, which I can also write like this, AB, has a length of 5. Okay, so that's Pythagorean theorem. That should be a review from middle school. Maybe the coordinate grid was a little bit new, but you should have seen Pythagorean theorem before. So we're also going to look at 2 other formulas today. I'm going to do distance formula next. And the reason I'm going to do that one next is because the distance formula actually comes from the Pythagorean theorem. Here's my formula. It is, actually, sorry, I'm going to write D equals for distance. All right, and it's x2 minus x1. That just means it's the second x coordinate minus the first x coordinate. And then plus y2 minus y1, same thing, second y coordinate minus first y coordinate squared. So this is actually a squared and b squared, and this is c. But in order to do that without a picture, we have to find the length by subtracting those 2 coordinates. So in these 2 examples, we do not have a picture to go with this or a coordinate grid. So the last one we did a coordinate grid, we could draw a right triangle. This one allows me to essentially find the lengths of the sides of the triangle without having to draw it or use a coordinate grid. So I'm going to call, here I'm just going to write out 1, 1, 4, 5. So this is like my x1, y1, right? An ordered pair is always x and y. So if this is my first coordinate, I'm just going to call it x1, y1. This one would then be x2, y2. So then my formula, distance equals x2 minus x1 squared. So 4 minus 1 squared plus 5 minus 1 squared, y minus y. Okay, so all I did is I substituted those values into this formula. And now I'm going to simplify. So I want to follow order of operations. I want to do the parentheses first. So everything's under this big square root. 4 minus 1 is 3. 5 minus 1 is 4. Okay, 3 squared and 4 squared. Then come up here next. Still under the square root. 3 squared is 9. 4 squared is 16. Add those together, I get 25. And then lastly, the square root of 25 is 5. So this is actually the same points from our previous example. So I'm going to kind of show those together here, you guys. All right, so the reason why we did 4 minus 1 is that gave me this length of 3. And the reason why we did 5 minus 1 is that gave me this length of 4. So that subtraction of the coordinates is what gives me the lengths of that triangle. And so that's essentially what the distance formula is. It's just Pythagorean theorem without having to draw a triangle. Okay? All right, let's try another one. Same thing. So I'm going to call this one my x1, y1, x2, y2. All right, so we've got our distance equals x2 minus x1. So we got negative 9 minus x1 is negative 3 squared plus y2 minus y1 squared. Okay, it's easy to lose track of the minus and negatives. That helps just to say it, I think, so that you make sure you write each one down. So this was x2 minus and then x1. Okay, so whenever I have the double negative next to each other though, right, it becomes addition. So negative 9 plus 3 is negative 6. I'm doing the parentheses first again. Negative 5 minus 5 is negative 10. Okay, anytime I square a negative here like this, I will always get a positive answer, which makes sense if I'm finding distance. I should get a positive solution. So negative 6 squared is 36. And negative 10 squared is 100. Okay, so I get 136 when I add those together. Now, this is not a perfect square. So I'm going to simplify using my perfect factors method. So I don't really know numbers that go into 36. So this is where, 136. So I might try my calculator with a few. So maybe I try 4. Sure, that one worked. Also, this is even, so I know I could have divided by 2 if I can't find another one. So 136 divided by 4 is 34, so we could do 4 and 34. 4 breaks into 2 and 2, 34 breaks into 2 and 17, and those are all prime. So these are my numbers I have left, pair of 2's means that 2 comes out front. 2 times 17 I put back together as 34. So that is my distance from A to B, or from D to C. So I also remember could write it, and I'm going to fix this one too, as AB and, all right. Okay, so Pythagorean theorem, distance formula, essentially the same thing. Distance formula just allows us to do it without a picture of a triangle. Okay, and it's when I'm given coordinates that are not on a grid and I can't draw a triangle. Okay, the last formula we're going to look at today, you guys, is something called the midpoint formula. And I'm going to write the formula first. So midpoint is the middle. So how I find the middle of something is actually the same as finding the average. So I'm going to find the average of the x's, which means I'm going to add the two x coordinates and divide by 2. And then I'm going to do the same exact thing with the y's. Okay, so there is our midpoint formula. So this says find the coordinates of the midpoint of segment CD given those two endpoints. Okay, so I'm just going to draw that so you guys can see what it's talking about. So we've got C, D. C has coordinates -2, -1. D has coordinates 4, 2. We want to find the coordinates of M. So of the midpoint. I'm going to call it M. So how I do this is I'm going to use my formula. So I'm going to add the two x's, -2 plus 4, and divide by 2. That'll give me the new x coordinate. And I'm going to do the same thing for the y's. -1 plus 2, and divide by 2. And then I just simplify. So -2 plus 4 is 2. 2 divided by 2 is 1. -1 plus 2 is 1. 1 divided by 2 is 1/2. So I'm just going to leave it like that. Okay. Perfect. All right, this one is a little bit different. They are giving me the midpoint. So they're saying AB is our segment. AB, M's the midpoint. Okay, so we are given that A has the coordinates 2, 2, and M has the coordinates 4, -3, and they want us to find the coordinates of B. So I'm not going to use my midpoint formula on this one because that is for finding the midpoint. We already know the midpoint. So what I'm going to use is I'm going to use what I know about the definition of midpoint. I know that these two segments must be congruent if M's the midpoint. That means the distance from A to M has to be the same, as from M to B. So we know I'm going to have an x coordinate and a y coordinate. So I'm going to look at the x's first. So from 2 to 4, the x's, they added 2. In order for this length to be congruent, I have to do the exact same thing to the x. So if I added 2 to get from 2 to 4, I'm going to add 2 again to get from 4 to this x coordinate. So if I add 2, I get 6. So the x coordinate must be 6. I'm going to do the same thing with the y's. So from 2 to -3, this time I went down. So I subtracted 5. Sorry, I'm going to kind of do a big loop there. So I went down by 5. I got to do that same thing to make sure I stay congruent. Same exact distance. So if I went down 5 to get to -3, -3 minus 5 more is going to get me to -8 for B. Okay, that's all the notes for 1.6. Thanks for watching.